So this kind of hairy looking expression, we're just dividing one complex number written in blue by another complex number. This first complex, actually, both of them are written in polar form, and we also see them plotted over here. This first complex number, 7 times cosine of 7 pi over 6 plus I times sine of 7 pi over 6. We see that the angle, if we're thinking in polar form, is 7 pi over 6. So if we start from the positive real axis, we're going to go 7 pi over 6. So we're going to go 7 pi over 6 all the way to that point right over there. And then from the origin, we're going to step 7 out. We're 7 away from the origin. So 1, 2, 3, 4, 5, 6, 7 to get to that point right over there. And then the second number, the angle is 7 pi over 4. So that takes us all the way around here. It takes us all the way. Actually, I should do it smaller since that has a smaller distance. So let's say we start over here. So we're going to go all the way over here to that point right over here. And its distance from the origin is 1. You can imagine that there's a 1 in front of that. And we want to divide the two. And I encourage you to pause this video and try to do this on your own. And then plot the resulting number when you divide this blue complex number by this green one. Well, as you might have realized, if you somehow just try to divide it straight up, it can get quite hairy, and the way to tackle it is to write it in another form. And what might have jumped out at you is that exponential form would be much, much simpler. And the way that we convert this to exponential form is to recognize that this business right over here is the same thing. This comes straight out of Euler's formula. This is e to the 7 pi over 6i. 7 pi over 6i. That's this expression right over here. So this entire top complex number could be rewritten as 7e to the 7 pi over 6i. And this bottom complex number can be rewritten as 1 times, so we don't really have to write the 1, but this bottom part right over here is going to be the same thing as e to the 7 pi over 4i. 7 pi over 4i. And this comes straight out of Euler's formula. And when you write it in this way, then we can just use exponent properties to simplify it. We have the same base, and so we can just subtract this exponent from that exponent right over there. So this is going to be equal to, well, 7 divided by 1 is just 7. So it's going to be 7 to the, or 7 times e. Let me do this in a brighter color. 7 times e to the 7 pi over 6i minus 7 pi over 4i. Minus 7 pi over 4 ith power. So what is this going to be equal to? Well, if I have 7 pi over 6 of something and I subtract 7 pi over 4 of that thing, how many do I have left over? Well, let's see. I'm essentially, let's just rewrite. Let me just rewrite all of this. This is really just about subtracting fractions at this point. So if I were to rewrite this, let's see, if I write it with a denominator of 12, then I'll have a common denominator. It's my least common multiple of 6 and 4. So this one I can rewrite as 14 pi I over 12. Or I can write it as 14 pi, actually, let me just write this, 14 pi I over 12, and then minus, so I multiply the numerator and denominator by 3, minus 21 pi I over 12 as well, right? I just multiplied numerator and denominator by 3 right over here. And so this is going to be equal to, I'm going to have 12 in the denominator. 14 pi I minus 21 pi I is going to be negative 7. Negative 7 pi I. So this thing is equal to 7e to the negative 7 pi I over 12. Now let's see if we can do a decent job of plotting this. So let's see, each of these increments that they've done, let's see, in each of these quadrants we have 1, 2, 3, 4, 5, 6. So they've split this quadrant into 6 equal angles, and this quadrant is pi over 2. So each of these are pi over 12. Each of these little sub-angles are pi over 12. So we're going to have negative 7 pi over 12. So we're going to go in the negative direction. We're going to go counterclockwise. Or sorry, we're going to go clockwise. So we're going to go, let me start here. And so if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 gets us right over there. Did I do that right? That doesn't. Let me make sure I got that. Let me make sure I got that. Negative 7. So each of these are pi over. Let me make sure. So this whole thing is pi. So we have 1. Oh, wait, let me make sure. This whole thing is pi. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So each of these are a 12th of that. So it's pi over 12. That's right. And we want to go negative 7 of them. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. Oh, yeah, I just kept going all the way to negative 12 the last time. So this is the angle. This is our angle right over here. And our distance that we go out from the origin is 7. So we go out 1, 2, 3, 4, 5, 6, 7. So we come out right over there. So this complex number divided by that complex number is equal to this complex number, 7 times e to the negative 7 pi I over 12. And if we wanted to now write this in polar form, we of course could. We could say that this is the same thing as 7 times cosine of negative 7 pi over 12 plus I sine of negative 7 pi over 12.